continue our linear motion exercise. We stopped at number 11. The question says, a car takes off from rest and covers a distance of 80 meters in 10 seconds. Calculate its acceleration. So rest means that the initial velocity u was what? 0 meters per second. The distance traveled, 80 meters. We are looking for acceleration. Time taken is 10 seconds. So here we have here we have A, S, U, and T. What formula connects A, S, U, and T? That's S is equal to UT plus half A T squared. So 80 meters, substituting, I'll get 80 meters is equal to 0 times 10. Initial velocity is 0, time is 10 seconds. So 0 times 10 plus half times A times 10 squared. We are looking for the acceleration. What does this give us? 0 times 10 is 0. So this side will disappear. We have AT is equal to half times A times 100. That means what? AT is equal to 50A. A will be 80 over 50, and A is 1.6 meters per second squared. That's the acceleration of the body. Question 12 now. Question 12. Question 12 says, a bus traveling at 15 meters per second accelerates uniformly at 4 meters per second squared. What is the distance covered in 10 seconds? So, bus initial velocity 15 meters per second. Accelerates uniformly at 4 meters per second squared. For what? 10 seconds. What is the distance covered in that 10 seconds? Sorry, I didn't draw velocity time graph for the last question. Let me draw it for this question now. Although it's not always composable, we are learning along, so it's important we learn how to draw the velocity time graph of motions too. So initial velocity is 0. The train was moving at an initial velocity of 4 meters per second before accelerating. For how many seconds? It accelerated for 10 seconds. The rate of acceleration was 4 meters per second squared. Let me write that one. 4 meters per second squared. That's the rate of acceleration here. That means the slope of this graph is 4 meters per second squared. The question says we should find the distance traveled. Here, distance traveled is area under the curve. So let's use formula. We can use formula, we can use area under the curve. If we want to use area under the curve, we need to find this side. And that's represented by the final velocity attained here. So we need to find this final velocity attained. After accelerating for 10 seconds, we need to find the final velocity attained here. Now, to get V, what do? To get V, I'll do V is equal to U plus AT. V will be 15, which is the initial velocity, plus 4 times 10. It accelerated at 4 meters per second squared for 10 seconds. So U plus AT will be 15 plus 4 times 10. That's what? 15. That's 15 plus 40, and that's 55. So the final velocity attained is 55 meters per second. So that means I have my two parallel sides of the graph. I have my A, I have my B. My B will be this side, 15. No, sorry. My B will be the length of this side, 55. My A is 15 here. So if I want to find the the graph using S is equal to area under graph. My distance is the area under the graph. The graph is trapezoidal, so that's half A plus B times H. Area of a trapezium is half A plus B times H. That will give me half times 15 meters per second plus 55 meters per second times what? H. H is the perpendicular height of the trapezium. This is the trapezium here. 1, 2, 3, 4. Can you see that? These are the two parallel sides, this side and this side. I know the length of the two parallel sides. The perpendicular height between them is here. This height is perpendicular to the two parallel sides. So my H is what? 10. That gives me my H as 10 seconds. So my distance is half times 55 plus 15, 70 meters per second times 10 seconds. Is that clear? Second, we cut second. What do I have left? I'm going to have 35 times 10, 350 meters. I can do that using the area under the graph, but I don't need to do that since I have all the parameters I need to find the area. Initial velocity was 15 meters per second. Let me write here that I'm using second method. In fact, this could even be our first method, but it's okay, we can take anyone first. We are looking for distance. We know the initial velocity as 15 meters per second. We know the acceleration as 4 meters per second squared. We know the time as 10 seconds. So we look for distance. What formula connects S, U, A, and T? Among the equations of motion, the formula connecting S, U, A, and T is S is equal to UT plus half AT squared. So that's 15 times 10 plus half times 4 times what? 10 squared. So that's UT plus half AT squared. So that gives me 150 plus what? 2 times 100. That's 150 plus 200. So the distance traveled is 350 meters. So you always get the same answer, whether you use the graph, or you use your formula. You always get the same answer. As long as you analyze the question well, you always get the same correct answer. Let's go to this was question 12. Let's go to question 13. In question 13, it says a body starts from rest and accelerates uniformly at 5 meters per second square. Calculate the time taken by the body to cover a distance of 1 kilometer. Now, a body starts from rest. U is 0 meters per second. Accelerates uniformly at 5 meters per second squared. Calculate the time taken to cover a distance of 1 kilometer. First thing, 1 kilometer is 1 times 1,000 meters. So the distance is what? The distance traveled is 1,000 meters. You change any one that's not in SI unit straight to SI unit. So what does this give you? We are looking for time. We have U, we have T, we have S and A. What formula connects U, T, S and A? That's the third equation of motion. S is UT plus half AT squared. Distance in this question is 1,000 meters. UT will be 0 times T because the body started from rest, plus half times A, that's half times 5 times T squared. Is that clear? So that gives you what? 1,000 is equal to, this will disappear. 0 times T will not be part of our answer again. 0 times T is 0. Half times 5T squared. So let's cross multiply. 1000 over 1 is 5t squared over 2. Let's cross multiply. That gives you 5t squared is what? 2000. Now t squared is 2000 over 5. T squared will be 2000 over 5. So t squared is 400. If t squared is 400, t is square root of 400. And t is 20 seconds. It will take 20 seconds to travel 1 kilometer, accelerating at what? At 5 meters per second squared. Let me see if I can quickly. Let's call this the first method. Let's call this the first method. Let me see if I can quickly explain a second method. Or there's no need. Let's just leave it like this. There's no need. No need. We'll get to questions that show us how to find time from distance. Let's go straight to question 14. Question 14 says, a particle starts from rest and moves with a constant acceleration of 0.5 meters per second squared. The distance covered by the particle in 10 seconds is, it moves with an it starts from rest, so that means its initial velocity is 0 meter per second. The acceleration is 0.5 meter per second squared. Time taken 10 seconds. Distance covered in 10 seconds is what? The suitable formula for this question too is S is ut plus half a t squared. Let me be sure. Okay, 10 seconds, 0.5 meter per second squared. That's correct. So the formula connecting S, U, A, and T is the third equation of motion, which is S is equal to ut plus half a t squared. Now, if you have ut plus half a t squared, your distance will be equal to 0 times time, 0 times 10. The initial velocity is 0, so you do 0 times 10 plus open bracket half times what? 0.5 times what? 10 squared. Half times 0.5 times 10 squared. What does that give you? That gives you, this will disappear. So all I have left is going to be half times 0.5 times 100. 10 squared is 100. So half times 0.5, that's 0.25. 0.25 times 100 is 25 meters. The distance traveled by the body is what? 25 meters. Number 15. In question 15 it says, a body accelerates uniformly from rest at 2 meters per second squared. Calculate its velocity after traveling 9 meters. Now, the body accelerated from rest. That means the initial velocity was rest, which is what? 0 meters per second. It accelerated uniformly at 2 meters per second squared and traveled 9 meters. You are looking for the final velocity after traveling 9 meters. Now here, you have a different set of parameters. The parameters you have involve U, A, S, and V. What equation of motion connects U, A, S, and V? That should be the fourth equation of motion. So you say using V squared is equal to U squared plus 2AS. V squared will be 0 squared plus 2 times A acceleration, which is 2 times 9. V squared will be 2 times 2 times 9. 0 squared will disappear. 0 squared gives 0. So that gives what? That gives V squared is 36. V is square root of 36. The final velocity after attaining 9 meters, after moving 9 meter distance, will be 6 meters per second. Let's go to question 16 next. question 16 next. Here it says a boy moving with a velocity of 3 meters per second is brought to rest by a constant force after traveling 15 meters. Calculate the retardation. So I'd like to draw a velocity time graph for this one, just to keep us learning how to draw velocity time graph. So time in seconds, velocity in meters per second. The boy was traveling at 3 meters per second. It was now brought to rest. Brakes were applied, and he was brought to rest. So rest is what? 0 meters per second here. Now, the distance traveled is the area under the curve, and it says that a distance of 15 meters was covered in the process. The question says, calculate the retardation. Calculate the retardation. Okay? What this means is that we know distance traveled, 15 meters. We know the initial velocity was 3 meters per second. We need retardation. What else do we know? We know final velocity was 0 meters per second. So we are looking for acceleration. Now we'll check what formula connects V, U, S, and A. What equation of motion connects the quantities U, V, S, and A? Sorry, I'm not doing it in order. But the equation connecting them is what? V squared is equal to U squared plus 2AS. Now, V squared is equal to U squared plus 2AS. We give you 0 squared is equal to 3 squared plus 2 times A. That's what? 2 times A times 15. So 0 is 9 plus 30A. 0 is 9 plus 30A. Now, minus 9. 0 minus 9 is equal to 30A. That means minus 9. That means what? Minus 9 is 30A. What does this give you? You do it very well. 30A is equal to minus 9. 30A is equal to minus 9. A is minus 9 over 30. A is minus 9 over 30. A is excuse me. I got a wonderful calculator here. So A is minus 0.3 meters per second squared. This means that it slows down at this rate. It slows down at this rate because that's a deceleration, a negative acceleration. Question 17 now. Question 17. A car moving with a speed of 90 kilometers per hour was brought to rest by the application of the brakes in 10 seconds. How far did the car travel after the brakes were applied? Okay. A car, initial velocity 90 kilometers per hour, was brought to rest in 10 seconds. So final velocity is equal to rest is equal to what? Let me write that one. A spacious environment. Final velocity is rest. So this is, something you are learning now. The final rest can be used as final velocity, and it can be the initial velocity, depending on what the nature of the motion is. So final velocity is equal to rest. That means it stops completely when it gets to 0 meters per second. Now, the question says what? The question says, how far did the car travel after the brakes were applied? how far did it travel after the brakes were applied. So we are looking for distance traveled. Now U is 90 kilometers per hour. Let's try and change this kilometer per hour to meter per second. 1 kilometer is 1,000 meters. 1 hour is what? 3,600 seconds. So that gives us what? That gives us 90 times 5/18, which is what? 25 meters per second. So our initial velocity is the same as 25 meters per second. The reason is that we cannot work kilometer per hour with time in seconds. You understand? They are not conformable. We can't work these two. We cannot manipulate the two together. Kilometers per hour and time in second. It's either we change this to hour or we change this to what? Meter per second, so that they can be uniform. All right, let's go. How do we get distance? In this question now, we have U, we have V, we have S, and we have T. So what formula connects U, V, S, and T? Those are the 4 parameters we have here now. We have initial velocity, we have final. We have distance, we have time. Although we are looking for distance. So it's still part of the story. How do we get the distance? The formula connecting UV, we'll use the formula connecting UV, S, and T. So that's the second equation of motion, whether second or first. The one that says distance is equal to average velocity times what? Time. Distance is equal to average velocity times time. So the distance traveled, it was initially moving at 25 meters per second. It was slowed down to 0 meters per second over 2 times what? Times 10 seconds. What does that give us? You can do it yourself. That gives us 25 meters per second over 2 times 10 seconds. That's what? 25 meters per second times what? 5 seconds. 2 we divide 10 to give 5. And we get what? Second here, we cancel out second. So you have 25 meters times 5. What does that give you? That gives us 125 meters. The distance traveled in that period is 125 meters. Number 18 now. An aeroplane lands on a runway at a speed of 180 kilometers per hour and is brought to stop. Stop is also the same thing as rest, or final velocity is equal to 0. And is brought to a stop uniformly in 30 seconds. What distance does it cover? Same as number 17. That's the same as number 17. Number 18. We are looking for distance. Okay, don't let me start with that. An aeroplane lands on the runway with a velocity of 180 kilometers per hour. Straightforward. Let's change 180 to meters per second. That gives what? 180 times 5/18. We got 5/18 from 1,000 over 3,600 upstairs. So earlier. So that gives what? 50 meters per second. That's our initial velocity. It was brought to rest. That means the final velocity was 0 meters per second. Everything happened under 30 seconds. You are now looking for the distance traveled. How do we get distance? We use the formula connecting U, S, V, and T. The equation of motion connecting U, S, V, and T is what? S is equal to average velocity. Distance traveled is average velocity times time. So distance is equal to average velocity, that's 50 meters per second plus 0 meters per second times what? 30 seconds. What does that give you? 50 plus 0 That gives 50 meters per second over 2 times 30 seconds. That's what? 50 meters per second times 15 seconds. You know how I got 15? 2 here, 1, 2 in 30, 15. And that's what? That's 50 times 15, 750 meters. That's a long distance. So aeroplanes travel so far like this before they finally stop. That's scary. So, that's how to use the equations of motion in solving simple problems on linear motion. We'll take a few more examples before I give you an exercise in the next video.